you wake up tomorrow and take a breath. It feels the same. The air is invisible, weightless, ordinary, the way it has been every single morning of your life. But overnight, something in the sky has changed. The amount of oxygen wrapped around this planet has quietly doubled while you slept, and your body is already reacting in ways you cannot feel yet. You might think more oxygen sounds like a gift. Cleaner lungs, sharper mind, endless energy. That is what your instincts tell you. Because oxygen is the thing that keeps you alive, so more of it must be better. But the truth is the exact opposite. Doubling the oxygen in Earth's atmosphere would not heal the world. It would set it on fire. To understand why, you have to understand what the air is actually made of. Right now, the atmosphere you breathe is only about 1/5 oxygen, roughly 21%. The rest is mostly nitrogen, a calm, unreactive gas that does almost nothing except take up space and dilute everything around it. That nitrogen is not filler. It is a safety buffer. It is the reason a single spark in your kitchen does not turn your entire home into a fireball. Now imagine that buffer shrinking as the oxygen climbs toward 40%. What happens to fire? Fire is not magic. It is a chemical reaction, a rapid marriage between fuel and oxygen that releases heat and light. The more oxygen present, the faster and hotter that marriage happens. In today's atmosphere, damp wood struggles to catch. A rain-soaked forest resists burning. A candle stays a candle. But scientists who study the chemistry of combustion have found that once oxygen rises past roughly 25%, even wet vegetation can ignite and sustain a flame, push it higher toward the doubled world, and the ordinary rules of fire dissolve entirely. A dropped match would not make a small flame. It would make a blast. A lightning strike on a distant hill would not start a containable brush fire. It would start a wall of fire that races across continents, faster than anything could outrun it. Rainforests, usually too wet to burn, would become tinder. The planet's green lungs would turn into fuel. Think about how much of your world quietly depends on things not catching fire. The wooden frame of your home, the pages of a book, the grass in a park, the dry leaves gathering in a gutter. In the atmosphere you live in now, most of these sit safely inert, needing real effort and real heat to burn. In a doubled oxygen world, that safety evaporates. The line between fuel and fire, which today is thick and forgiving, would thin to almost nothing. A stray ember from a barbecue could level a neighborhood. A car crash would not risk a fire. It would guarantee an inferno. This is not a wild guess. It is written into the rocks. Here is the part that should stop you cold. Earth has already lived through an age of extreme oxygen, and the evidence is buried in stone all over the world. Around 300 million years ago, long before dinosaurs, there was a stretch of deep time that geologists named the Carboniferous period. The name itself is a clue. Carboniferous means coal-bearing, because this era left behind the vast coal seams we still dig out of the ground and burn today. Those coal beds are the crushed, fossilized remains of enormous ancient forests, and those forests were breathing out oxygen at levels our modern world has not seen since. How high did it climb? Yale University geochemists, including the influential work associated with Robert Berner, built detailed models of ancient atmospheres by tracing chemical signatures locked in sediment and rock. Their reconstructions suggest that during the Carboniferous, atmospheric oxygen may have surged to around 35%, far above the 21% you breathe now. The world was soaked in it. And that world grew monsters. You have probably seen a dragonfly, palm-sized, delicate, harmless. Now picture one with a wingspan as wide as a hawk. That creature was real. Its name was Meganeura, and its fossils show a predatory insect with wings stretching more than 2 feet across, gliding through Carboniferous swamps. Crawling below it was Arthropleura, a millipede-like arthropod that could grow longer than a human is tall, a segmented giant rippling across the forest floor. There were spiders, scorpions, and cockroaches, all swollen far beyond anything alive today. So let us stand inside that ancient forest for a moment and picture exactly what it looked like. The air is heavy and humid. Towering tree ferns rise into a green canopy, and the ground is a soft, waterlogged tangle of rotting plants. Above you, a shadow passes. It is Meganeura, wings shimmering, hunting smaller insects on the wing like a bird of prey. Near your feet, the leaf litter shifts, and a segmented body as long as your leg glides past without a sound. Nothing here is poisonous to you. Nothing is hunting you. And yet every instinct screams that this world is wrong, because the scale of life has been quietly turned up, and the reason floats invisibly in the air all around you. Why did the bugs get so big? The answer reveals something strange about how insects are built, and it is the key to everything. Insects do not breathe the way you do. You have lungs. You pull air into a central organ, load oxygen into your blood, and your heart pumps that oxygen everywhere it needs to go. Insects have no lungs and no oxygen-carrying blood in the way you do. Instead, their bodies are threaded with tiny tubes called tracheae, little pipes that open through holes in their exoskeleton and carry air directly to their tissues. Oxygen simply diffuses through these tubes, drifting inward on its own. That system has a hard limit. The bigger an insect gets, the longer those tubes have to be, and the harder it becomes for oxygen to passively reach the deepest tissues. In today's thin oxygen, an insect can only grow so large before its innermost cells start to suffocate. That is the invisible ceiling pressing down on every bug you have ever seen. It is why there are no dog-sized ants scuttling through your garden. But raise the oxygen, and you raise the ceiling. Biologist Robert Dudley, working at the University of California, Berkeley, has spent years studying insect flight and the effects of oxygen-rich air, and his research explores how higher oxygen concentrations may have allowed ancient insects to power larger bodies and take to the skies. More oxygen in the atmosphere means it penetrates deeper through those breathing tubes, letting the animal grow bigger before hitting the wall. The giant insects of the Carboniferous were not a fluke. They were what happens when the air itself invites gigantism. So here is the unsettling thought. If oxygen doubled and stayed doubled for long enough, evolution might slowly rebuild that lost world of giants. Not overnight, but over generations in a super-oxygenated sky, the ceiling that keeps insects small would lift again. But the strangest part is still ahead, and it changes how you should picture this entire scenario. Because the danger is not only in the forests or the fossils. The danger is inside you. You have always been told oxygen keeps you alive, and that is true. But too much of it becomes a poison. This is a real medical condition, known and documented, called oxygen toxicity. The idea reaches back to the 19th century French physiologist Paul Bert, whose pioneering work on the effects of gas pressure on the body first revealed that oxygen, at high enough levels, can turn from life-giving to toxic. When your body is exposed to oxygen at high enough pressures or concentrations for long enough, that same molecule you depend on begins to attack you from within. How does something so essential become a weapon? The answer is that oxygen is chemically aggressive by nature. It is the same reactivity that lets it power your cells, and the same reactivity that makes fire burn. Inside your body, an overload of oxygen generates unstable molecules that damage tissue at the cellular level. It can inflame and injure the delicate lining of your lungs, making each breath harder instead of easier. At the extreme, it can disrupt the nervous system and trigger seizures. Deep sea divers already know this danger intimately, because breathing oxygen-rich mixtures too deep can turn the gas dangerous, which is why their equipment is so carefully calibrated. What keeps them alive at the surface can kill them below. In a permanently doubled atmosphere, your own biology would slowly turn against you. The gift becomes the wound. The very thing you reached for in that first grateful breath would begin, cell by cell, to corrode you from the inside. Now let us stand inside that world for a moment and watch it unfold, exactly as it might happen. The first day feels euphoric. People report feeling lightheaded, giddy, strangely energetic. Wounds seem to heal a little faster. Then the fires begin. Somewhere, an ordinary spark meets ordinary fuel, and instead of a small flame, there is an explosion. A discarded cigarette, a kitchen stove, a car engine. Each becomes a potential detonation. Firefighters find that water barely helps, because in this thick oxygen, flames roar back the instant they are given anything to feed on. A fire that would take an hour to spread now crosses a city block in minutes. The tools built for our old gentle atmosphere simply do not work anymore. Whole fire departments, whole emergency systems are suddenly obsolete against something that behaves more like an explosive than a flame. And every burning tree, every burning building pours more heat into a sky already primed to ignite. Within weeks, the forests are gone, and with them, a staggering amount of the fuel that let those fires spread. The atmosphere is choked with smoke and ash. And here is the cruel twist that ties it all together. Those fires would not just destroy, they would consume oxygen at a furious rate, burning through the very surplus that started them, until the atmosphere slowly clawed its way back toward balance, scorched and emptied of forests, but breathable again. That is the pattern hidden in Earth's deep past. Scientists studying the Carboniferous have long noted the incredible abundance of fossilized charcoal from that high oxygen age, the burnt fingerprints of ancient wildfires preserved in stone. A superoxygenated world is a burning world. The planet does not tolerate that much oxygen for long. It corrects violently through fire. So what does this actually mean for you right now, breathing your ordinary 21% air? It means the atmosphere you take for granted is not an accident, and it is not merely comfortable. It is finely, almost impossibly balanced. Just enough oxygen to run every cell in your body. Just enough nitrogen to keep the whole planet from igniting. Move the dial just a few percent in either direction, and the entire character of the world shifts. A little less, and fires struggle and your lungs strain. A little more, and the forests grow tinderous, and your own cells begin to suffer. You live inside a window so narrow, it is almost frightening once you see it clearly. The Smithsonian and researchers across the Earth, sciences describe this balance as the product of billions of years of interaction between rock, ocean, plants, and air. A system that settled into the narrow window that makes complex life like you possible. Slide too far in either direction, and the world becomes hostile. Too little oxygen, and you suffocate. Too much, and you burn. You spend your whole life ignoring the air. It is the one thing you never think to be grateful for, because it has never once failed you. But that invisible ocean pressing against your skin right now is holding a razor's edge, and the fact that you can read this, think this, and breathe without a second thought is the quiet miracle underneath everything. Every other planet we have ever found is either frozen, poisoned, or barren. This one alone settled into the exact recipe that lets a creature like you exist and wonder about it. That is not something to take lightly. So tomorrow, when you wake up and take a breath, and it feels the same as always, remember what that ordinary breath is really protecting you from. The air is not just keeping you alive. It is keeping the world from burning.